DESSIN – Demonstrate Ecosystem Services Enabling Innovation in the Water Sector. Water scarcity and water quality problems are increasing in many parts of the world. Further human activities and climate change can lead to situations where water resources are scarce or of poor quality. This can cause economic loss, environmental degradation, and negative impacts on human health and quality of life. In this context, the DESSIN project has demonstrated solutions to tackle challenges related to water scarcity and water quality, with special focus on European urban areas. DESSIN is a research project funded by the European Union. 21 organisations from 7 European countries worked together under the coordination of IWW Water Centre from Germany. The main objectives of DESSIN are: demonstrate technical solutions for water scarcity and water quality issues, and develop and apply a methodology to evaluate the benefits of these solutions in terms of ecosystem services, shortly called ESS, as well as their sustainability. But what are ecosystem services? Ecosystem services are the benefits that society gains from the environment, for example, clean water and air, decomposition of waste, pollination of crops, or even the recreational value of a beautiful landscape. If we can quantify these services and express their value in monetary terms with a tool, this is helpful for assessing the environmental and societal effect of a new technology or management solution. One of the main challenges when implementing new technologies or policies is the limitation of existing comprehensive frameworks to compare new alternative solutions and established ones with regard to their broader effects. To change the situation for the water sector, DESSIN has developed the Ecosystem Services Evaluation Framework, a tool enabling a standardized evaluation of impacts from innovative measures on ecosystem services. The tool considers the environmental, economic and social dimensions to enable better decision-making and to generate additional arguments for market uptake and practical implementation of new solutions. To validate and test this methodology, the Ecosystem Services Evaluation Framework has been applied to 5 demonstration sites across Europe, located in Westland in the Netherlands, Llobregat in Spain, Athens in Greece, Emscher in Germany and Hofselve in Norway. Let's discover what has been demonstrated in each demo site. The Westland demo in the Netherlands site is located near the North Sea, in one of the world's largest horticulture areas. Due to seawater intrusion, the resources of fresh water in coastal areas are limited, while demands are high, resulting in freshwater scarcity for drinking water, industry and agriculture. Rainwater is the most suitable freshwater source for horticulture, but the challenge is how to harvest and store this freely available water of high quality. Above-ground basins are one option, but these basins are limited in volume. Another challenging option is to store excess rainwater in the subsurface by using aquifer storage and recovery, shortly called ASR. However, the situation for this technique in coastal areas is rather complicated due to the presence of brackish and saline groundwater. The Westland team demonstrated that the potential of storage and recovery of fresh water in saline aquifers significantly improves through innovative well design by combining aquifer storage and recovery solutions with reverse osmosis desalination. This concept is called ASRRO, aquifer storage and recovery combined with reverse osmosis. In the Westland demonstration site, rainwater is infiltrated at various depths in the aquifer. At the abstraction stage, fresh water is recovered mainly from the upper layer of the aquifer. By also extracting brackish water from the deeper layer of the aquifer and treating this water with reverse osmosis, the recovery of fresh water is much higher than with conventional well design. ASRRO proves to be a very promising solution for freshwater scarcity problems in coastal areas. Moreover, due to ASRRO, further salinization of coastal aquifers can be limited. This pilot case has developed into a regional showcase, with the aim to support scale-up and application to other coastal areas in the world. In Spain, the Llobregat team has improved the environmental and economic sustainability to the managed aquifer recharge facility of Aguas de Barcelona by injecting pre-potable instead of potable water into their aquifer storage and recovery system. The pre-potable water comes only from the conventional treatment of the Llobregat River water, thus saving the energy and the use of chemicals that are needed for the advanced treatment to achieve drinking water quality. For 1 year, this procedure was tested before the impact of the recharge on the quality and quantity of the water in the aquifer has been evaluated. To understand the impact, different variables such as salinity, nutrients or indicator microorganisms have been monitored in the injection zone and its surroundings. The application of statistical techniques on the analytical results, along with the modelling of the recharge on a real scale, has demonstrated the positive impact that recharge with pre-potable water has on the aquifer, improving the environmental and economic sustainability of the current system. The city of Athens in Greece has suffered rapid urbanisation, resulting in few urban green spaces. This fact, coupled with peri-urban forest fires in the last decade, has resulted in severe degradation of its environment and the quality of life of its inhabitants. To irrigate these and create new urban green spaces, in a water scarcity context, we need innovative management options and technologies for water reuse. At the Athens demo site, DESSIN has demonstrated a fully automated packaged treatment plant that mines wastewater directly from the sewer network, treats it and reuses it at the point of demand. The unit can be remotely monitored and operated, and its performance data are recorded in real time, to allow operators to visualize all relevant information and make timely decisions. The sewer mining unit consists of 2 subunits, a membrane bioreactor (MBR) and a reverse osmosis (RO) unit. Both have been constructed as individual packaged modules that are joined together in one compact system, offering high efficiency, remote operation and monitoring, as well as ease of transportation. The double membrane treatment scheme tested, MBR-RO, achieved very high quality of treated effluent, which can reliably meet all national and international standards for all types of non-potable wastewater reuse at a moderate cost. Application of this solution in Athens has revealed several additional benefits in the form of ecosystem services. We found, for example, that irrigating green spaces with sewer mining can significantly mitigate the urban heat island effect, and therefore lower energy demands and related costs for air conditioning in nearby neighbourhoods. We also explored how such units can be deployed either by water companies or SMEs in partnership with water companies, creating green jobs and services. Two demonstration technologies have been pilot tested in the Emscher catchment in Germany: a lamella settler at a combined sewer overflow facility, and a real-time control system to regulate the sewer system, both focused on water quality issues. The aim is to decrease the amount of combined sewer overflow and to improve the quality of the overflowing water, and thus to enhance water quality in recipient rivers. The lamella settler pilot container increases sedimentation of solids in stored combined sewage, and therefore pre-treats the water before overflow into a recipient stream occurs. The pilot real-time control system controls the water levels of 5 CSO facilities in the upper Emscher River section. This innovation allows an optimal utilization of the entire available underground storage volume, with the final aim to reduce pollutant input into streams by reducing the overflow frequency and volume from CSOs into streams. The Hofsova River in Oslo, Norway, flows through an increasingly populated and urbanized area. As an important natural element in the urbanized environment of the lower catchment part, Hofsova River provides recreational services which are affected by the water quality. Along the river, there are several combined sewer overflow facilities, shortly called CSOs. During heavy rain events, they discharge untreated water with a high content in sewage garbage and particles, as well as nitrogen and phosphorus, into the river. Therefore, DESSIN has demonstrated local treatment solutions for the overflow from CSOs. At Hofsaufer, two technologies have been demonstrated: a modular cross-flow lamellar settling unit for the local treatment of combined sewer overflows from detention tanks, and a high-rate filter solution that can be installed on the CSO outlet pipe for smaller structures without a detention tank. The results demonstrate that there are feasible solutions to mitigate some water quality problems caused by CSO. They can be a cost-efficient alternative to increasing the hydraulic capacity of a sewer system. More than 50 researchers have been working together for 4 years to develop and demonstrate the DESSIN solutions, and the DESSIN ESS evaluation framework tool has been successfully applied at all demo sites. It could be proved that a harmonized methodology to evaluate ecosystem services and sustainability in the water sector is possible and applicable. Giving value to ecosystem services can improve decision-making in water management and provide new arguments for market uptake and practical implementation of new solutions. Apart from that, DESSIN has delivered a portfolio of technical solutions for water scarcity and water quality challenges, which have been validated in the 5 demonstration sites across Europe. To learn more about the results of DESSIN, please visit www.dessin-project.eu. DESSIN. Demonstrate ecosystem services enabling innovation in the water sector.